Hey, it's Team Super Awesome. Today doing our team interview. I have myself as Deanna Medlock, Heather Arcos, Matt Paul, and Athena.
Deanna, what is an asymptote?
Thank you for asking, Heather. An asymptote is a place on the graph where the data would be undefined, meaning it would never reach zero. It would never cross the x-axis. A straight line that is the limiting value of a curve can be considered as tangent at infinity. The asymptote of the curve, the straight line, is a line traced by a point traveling in a constant direction, a line of zero curvature. The shortest distance between 2 points is a straight line. Heather, is it beneficial to know how to calculate the half-life of medications?
Well, I believe it is. Knowing how to calculate the half-lives of the medicines can be beneficial because it would just tell you how long the medication stays in our system and when it's time to take more or it's still time to wait. Let you know if it's safe, especially if you're giving it to like a patient or me as a parent. Like on mine, I did the half-life of albuterol for my daughter. She has asthma. So it was just good for me to know that after 6 hours of taking her medication, she still had some in her system, not, a whole lot, but at least she had half of the medication after 6 hours. So she can go to school and still have enough medication for the day. Thank you for asking that question. Matt, what is the purpose of knowing the half-life of our medications?
Thank you for such a clever question. Okay, so the purpose of knowing the half-life of our medication has a really simple answer. We should know this information because it is important when deciding the correct time to take another dose and to measure how effective the medication is working. We can then provide this information to our doctor and get a better dose and even a better medication in the future if that's needed. Thank you. Heather, what is the difference between correlation and causation?
Okay, correlation and causation are different because correlation is usually defined as a measure of the linear relationship between two quantitative variables. That there's some type of relationship between two variables. Causation is the act of causing change in something else. Just because something is correlated doesn't mean that's the cause. There is correlation with the acres planted of BT corn in the U.S. and the declining health of people. As my graph shows, that the more acres planted of BT corn, the number of people with a diagnosis of inflammatory bowel disease have been on the rise. It shows a correlation. It doesn't show the causation, but it shouldn't be ignored. Thank you for asking that. Matt, has inflammatory bowel disease been on the rise since the introduction of GM crops?
Thank you, Heather. The short answer is yes. Since the introduction of GM crops in our country, the rate of inflammatory bowel disease has been on the rise, as shown in the graph we made for this assignment. Our assignment shows that the correlation of use of BT corn is one of the causations for the rise in this disorder within our population. Thank you. Deanna, how do we become impaired and how does it affect our reaction time?
Well, it's always good to know at what point do we become impaired because the amount of alcohol a body can process depends on the type of drink, a person's weight, and the serving size of the drink being consumed. One drink is considered to be a 12 fluid ounce beer, one 5-ounce glass of wine, or 1.5 fluid ounce shot of liquor. The general rule of thumb is it takes about 3 drinks an hour for a woman to reach a 0.08 blood alcohol consumption level, and it takes about 4 drinks an hour for men. but these are general guidelines based upon the weight of the person drinking. So for a person who weighs 100 pounds, it will take about 3 drinks an hour to reach a 0.8 blood alcohol consumption level. At 140, it takes about 4 drinks an hour. At 180, it takes about 5 drinks an hour. And at about 220 pounds, it takes around 6 drinks an hour to reach the blood alcohol consumption level of a 0.8. The distribution curve created a nice bell-shaped curve. It is normally distributed, which means that we didn't have anyone who had an outrageously low reaction time or an outrageously high reaction time. Thus, the reaction times had a normal distribution. The mean reaction time for someone who had a 0.08 blood alcohol level was 2.4 seconds. It doesn't report what the task was, but seems like a long reaction time in comparison to how long it would take you to pick up your phone, for example. Heather, what are our Arkansas state tax dollars spent on?
Okay, in Arkansas, our tax dollars are spent in a number of ways. Just like our federal taxes, most of the money is spent on Medicaid or shown in a category of other. It doesn't really say what other is. That would be kind of interesting to know what our money is spent on. Then we look at the education category, and it shows that 15% of our state taxes are spent on both K through 12 and education and higher education. That's at least more than our federal tax dollars, which I think was only about 2%. Deanna, how do we measure skewness?
I found this very interesting to really understand more properly how to read this specific graph that we've continued using and not fully understanding it. So it's one thing to look at 2 sets of data and determine that one is symmetric while the other is asymmetric. It's another to look at 2 sets of asymmetric data and say that one is more skewed than the other. It can be very subjective to determine which is more skewed by simply looking at the graph of the distribution. This is why there are ways to numerically calculate the measure of skewness. One measure of skewness, called Pearson's first coefficient of skewness, is to subtract the mean from the mode and then divide this difference by the standard deviation of the data. The reason for dividing the difference is so that we have a dimensionless quantity. This explains why data skewed to the right has positive skewness. If the data set is skewed to the right, the mean is greater than the mode, and so subtracting the mode from the mean gives a positive number. A similar argument explains why data skewed to the left has negative skewness. Pearson's second coefficient of skewness is also used to measure the asymmetry of a data set. For this quantity, we subtract the mode from the median, multiply this number by 3, and divide by the standard deviation. Skewed data arises quite naturally in various situations. Incomes are skewed to the right because even just a few individuals who earn millions of dollars can greatly affect the mean, and there are no negative incomes. Data that are skewed to the right have a long tail that extends to the right. An alternate way of talking about a data set skewed to the right is to say that it is positively skewed. In this situation, the mean and the median are both greater than the mode. As a general rule, most of the time for data skewed to the right, the mean will be greater than the median. In summary, for a data set skewed to the right, you will always have a mean greater than the mode, you will always have a median greater than the mode, and then most of the time, the mean is greater than the median. The situation reverses itself when we deal with data skewed to the left. And that was what I found really interesting. Matt, how does wealth distribution look in the U.S.?
Thank you, Deanna. I'm often fascinated by this subject because there is virtually no distribution of wealth in the U.S., according to the research that we did for this assignment. The top 1% own over 35% of the wealth, while the rest of us in the bottom 40% only own a measly 0.9% of the wealth in our country. So it has been proven time and time again that the trickle-down economics theory does not work. So, thank you.
This conducts our team interview. Thank you for taking the time to watch our video.
Bye.
Bye.
Mm.